Hey everyone, let's take a look at circles. So a circle is the set of all points whose distance from a central point is the same. That distance is called the radius. For circles, we're almost always using a formula. To begin with, we've got the measure around the outside of a circle. That's called the circumference. To find the circumference, we multiply 2 times pi times the radius, or simply pi times the diameter. The next measurement is the area. For the area formula, we're going to take pi times the radius squared. And when we're doing this, we can almost always just approximate pi as 3.14. That's usually good enough. So that means if this circle right here has a radius equal to 7 meters, then the circumference of this circle is 2 times pi times 7, which is 14 pi, which is 3.14 times 14, 16, skip a space, 4, 3, add up, 6, 3, 4 with 2 decimal places, 43.96, what did I say? And the same thing for the area. The area is pi times the radius squared, so that's pi times 7 squared, so that's 49 pi. That's going to be 3.4 times 40, it's a 6, 12, 8, skip a space, 16, 5, 2, up, 6, 8, 13, 5, 2 decimal places, 153.86 meters squared. Cool. Let's take another circle. This circle's got a radius of 8 feet. I'll mark it right there. How long is 1/4 of the circle? Well, the circumference of this whole thing is 2 times pi times the radius, or 8. Let's be lazy and let's call this 16 pi. We can leave it in terms of pi because we're doing math. And when you're doing math, you can just write pi and not bother with the 3.14 business. And we want 1/4 of the way around, so that's 1/4 of the circumference is 1/4 of 16 pi, which is 4 times pi. Cool. And the other way that we could come up with 1/4 is we could say that this angle is 90 degrees. And 90 degrees out of the 360 degrees in an entire circle reduces down to 1/4. So this measurement right here is what part, what portion, what fraction of a circle. That's what we're looking at. What part of a circle do we? So what if instead we have 1/8 of a circle? Well, that's going to be our circumference times the 1/8. So if the circumference is 16 pi like we had before, then that means 1/8 of the circumference is 1/8 of 16 pi is 2 times pi. And in this case, this would be, it looks to be about 45 degrees, right? And 45 degrees divided by 360 degrees is, sure enough, 1/8. And again, this is what part of a circle do we want? And that's the formula that we have right here. If we're talking about the length of an arc, we take what part of a circle that we want, and then we multiply it by the circumference formula. If we smash it all together and we reduce 360 and 2, we get pi r, the degree measure of that arc, over 180. I think this idea right here is easier to remember. And it's no harder to calculate if you're on a calculator. If instead we're using radians, wherein the entire span of a circle, this is 2 pi radians, if that's equal to our angle measure, then the arc length is really simply the radius times the amount of radians. So if it's 2 pi all the way around, half the way around is pi, a quarter of the way around is pi divided by 2. So if r is equal to 8, and we're talking about pi divided by 2 radians, then that arc length is 8 times pi divided by 2, 4 pi, which matches what we found a few slides ago, which matches what we found all the way back here. So let's see here. A circle has a radius of 4 feet, an arc spanning 35 degrees has a length of, we're going to take and do, 4 feet is my radius, 35 degrees is that arc measure. I'm actually going to stick 35 degrees over 360 degrees, multiply it by the circumference. I'm going to do 35 degrees over 360 degrees times 2 times pi 4. So this is 35 times 8 times pi over 360, whatever that is. And we could leave it in terms of pi, 0.778 times pi feet, or we could use our approximation for pi to get 2.443 feet. Either way works. What about area? Well, we had that the area of a circle was what? Pi r squared. So if I want the area of half of a circle, it's got a radius of 2 meters, then the area of the full circle is pi times 2 squared, or 4 pi meters squared. So 1/2 of that area is, you simply divide it by 2, 1/2 times 4 pi, which is 2 pi meters squared. Again, we think about what part of the entire circle. And if I'm talking about degrees, this is 180 degrees and half of a circle. 180 degrees over 360 degrees, that reduces down to 1/2. This is half of a circle. For example, radians, it's a little bit harder. It's the amount of radians divided by 2. A little bit weirder, but that's fine. We don't really use radians too much in application. More of a calculus. So let's take a circle with a radius of 15 feet and let's find the area of a 20-degree sector. That's going to be our sector area here. 20 degrees out of a possible 360 degrees times pi times 15 squared. 20 out of 360 is 2 out of 36, and 15 squared is 225. So this turns out to be 225 over 18 pi. And this is feet squared. Or, you know, we go ahead and act all civilized like and get ourselves a calculator to get the number of square feet we want. We won't worry about the radians example here. Let's do one more. Let's take a look at this example right here. We've got 100 degrees, 32 feet, and we're trying to find the arc length and the sector area. So this length S is going to be 100 out of 360 times 2 pi times 32. So that's 100 out of 360 times 64 pi. And you know what we can do? We can get a calculator. And we don't need a fancy calculator for this. This is a calculator that just comes installed in Windows, and it's got a key for pi, so we can use that. 100 divided by 360 times 64 pi gets us our answer, 55.85. I think that's good. And as far as our sector area goes, it's again going to be 100 out of 360 times 32 squared times pi. We can again grab our calculator. 100 divided by 360, 32. We'll just times 2 because I don't always trust these. 893.61. 893. I always forget what the order of operations. That should do it. I will see you next time. Enjoy.